Thank you guys for coming out to the first week of our 6-week curriculum series. So this is a course designed to bring you guys to a basic proficiency of SolidWorks. So it doesn't matter how much experience you have right now. Our promise is that by the end of this, you'll be able to have working knowledge for you guys to be able to apply in your clubs here at UCLA, or for personal use, or even at internships. So let's begin. If you haven't done already, please sign in both on our Google form as well as on Meetup. The Meetup link should be at this card link right here. It's also always going to be up there if you guys want to get to that throughout the workshop. So first, let's introduce who we are. The organization itself used to be under the SolidWorks Student Leader Program. It's now part of the SolidWorks User Group Network, and basically the main difference is that the SolidWorks User Group Network is international, so they have basically a club on every manned continent, or populated continent, and as part of this network, we're able to receive a lot more information from SolidWorks, a lot more funding, a lot more resources, and using these resources, we aspire to deliver these to you, so that's including information about student licenses, which I believe a lot of you guys are running right now. The SolidWorks certification program, which includes a CSWA and CSWP, if you guys have heard about those. Those standing for Certified SolidWorks Associate and Certified SolidWorks Professional. And these are certifications that are basically internationally recognized. You put them on your resume, people know what it means. It's a standardized test, and it's very useful for resumes, for career fairs, etc. And lastly, career opportunities, user group network events, and etc. And generally, to promote further development into design and engineering. And we work closely with UCLA student organizations and other engineering departments. So to this point, can you guys shout out like where you heard about this workshop? Just like 3? Or no, that probably won't work.
Not at once.
Sorry, that's probably not a bad idea. Okay. But yeah, basically you guys probably heard about this from either an email blast from a UCLA organization, you heard it from somebody else who heard it through an email blast, or you came from an organization that we directly partner with. Okay. So who are we? I'm Abraham. I'm the co-president. Suraj is not here. He's in Singapore on study abroad.
I'm Colin. I'm one of the workshop leads. I'm a third-year aerospace engineering major.
Hello, I'm Nathan. I'm a second-year Mech E, and I teach SolidWorks. I'm a workshop lead.
Hi guys, I'm Luke. I'm publicity director, and I also lead workshops sometimes. And I'm a second-year Mech E as well. And did you go over your year, Abe? He's a fourth year. Also go over SolidWorks experience in years. 5 years.
Same as him, 5 years.
2.5.
6, maybe? I don't know. I haven't counted. I don't know. I don't know if that's correct. So I was thinking for this to go around the room and each say our name, but that might take a little bit long. And we already kind of did the socials courtesy of
No, yell
Luke.
your name out right now. And then at 3, 2, 1, you yell your name out, and then hopefully the person next to you hears his name, okay? Abe will count down.
3, 2, 1.
That was it, great. Next time we'll do better.
We'll do it again next week.
But you actually get to know each other.
During the lecture, you can talk to your neighbor.
No, you can talk to anybody.
You can actually talk to anyone. Yeah, you're not limited by your neighbor.
Okay, good job. So next slide. Okay.
Actually, wait, I have a full. How many of you have used SolidWorks before?
Okay, decent amount.
How about just CADing in general? So Fusion, AutoCAD. How many of you have never used CAD then? Should be the rest. Okay. Good balance, good balance. About a third.
Nice. Okay. Next, we'll move on to our game plan. We'll start with general logistics. So since you all are here, I assume you guys mostly know what the schedule is going to be like for the next 6 weeks. It's going to be every Tuesday until week 7, starting from now. From 6 to 8 p.m. here, this is Bolter 3440 if you want to tell other people where it is. And it will be a mix of lecture content, including lecture slides, as well as guided workshop content in SOLIDWORKS. And outside of class, we will have homework assigned weekly. This is optional, but highly recommended for you to reinforce your learning inside of class. And we also plan on holding a final project. This is still slightly tentative. That will be graded on week 6. Graded as in just like judged and like presented. And we'll have some time week 6 instead of workshop. We'll just have work time and judging time. In terms of office hours, we have none scheduled, but feel free to join our Discord server. Again, the link is on that card, the card link, the card.co link. And feel free to DM any one of us. Do note that since Suraj is in Singapore, he is in a different time zone. So if you DM him, he will have a longer response time.
If you double message him, he might respond earlier.
That is true. That is true. In terms of weekly topics, this is week 1, so we'll just have our introduction to SOLIDWORKS and basic sketching. Next, we'll move on to simple feature creation. These are your bosses and bases, if you guys are familiar with SOLIDWORKS. If you aren't, that's fine, we'll cover it. Next is advanced feature creation, then auxiliary design tools. This is like configurations, variables, relations, and assemblies. Week 5 will be creating engineering drawings, and week 6 will be, as stated before, the final project work time and judging. So, I know it's late, but some theory is important for dealing with CAD. I'll try to keep it as short as possible. So CAD is computer-aided design, as I'm sure many of you know. And you have this very general definition from Wikipedia. It's basically, the reason why we use CAD is because before we used to use paper, and paper, you literally have to walk it to somebody. CAD, you could just, email it, send it over Discord, whatever. And also, CAD allows for the integration of many different tools into one package. So I was talking with like an older engineer last week, and he said that there used to be I think, company that he worked for. You had to take your physical drawing, and you had to walk it down to the one person in the entire company whose one job was to calculate the mass of your part, and then he would like call you later with the mass. So instead of doing that nowadays, we have SOLIDWORKS, and then you just press a single button. And in terms of other CAD packages, there's CATIA, which is also created by Dassault Systems, which is a parent company of SOLIDWORKS. PTC Creo, which is also American. Onshape, also created by PTC. This is a browser-based solution if you guys don't want to download anything. Siemens, which is German, so mostly European audience. SOLIDWORKS combines part modeling, assembly, drafting, or drawing, simulation, and visualization. But in these workshops, we'll primarily be covering the first 3. But in your clubs here at UCLA, you're probably going to use all of them. So next, I'll just briefly discuss what is parametric modeling. So parametric modeling is versus direct modeling. And basically, parametric modeling can kind of be illustrated by building like a stack of blocks. So it's very structured. You create one feature, then you create the next, and you create the other. And direct modeling can kind of be illustrated by Blender. If you guys have used Blender, it's kind of parametric, as in you can define like different boundaries, like how big something is, but there's also the capability to just have a blob, and then you just form the blob into something that looks like what you want it to look like. So SOLIDWORKS is parametric. It does have some direct modeling, but it's mostly parametric. And then we come to this term called design intent. Design intent is basically encapsulates these 4 things: model efficiently, model intuitively, model for revision, and model for manufacturing. Basically, design intent is if somebody else wants to modify your part, will they be able to figure out how you made it without having to, get on a phone call with you or have a very lengthy conversation. So it's basically just be reasonable with how you design your parts, be efficient. This is encapsulated in design intent. So just a short illustration of what design intent might look like while creating a part. Here we have a power strip. Hopefully you can see that this is a power strip. And so there's a couple of ways of making this. There's an additive way and there's a subtractive way. Could somebody tell me what I might mean by those words? Like how would you create this? There's a couple of different ways. Yeah.
So additive would be you start like with a 3D printer, and then subtractive would be you start with a block of metal and then you subtract away.
Sure. Yeah, that's a good analogy. 3D printing versus regular machining methods. Machining is subtractive, 3D printing is additive. But in this case, additive is a little bit less granular than 3D printing. Additive in this case is you create, oh, I have a pointer? Oh, I do have a pointer. So additive is like you create this bottom block, then you create these little kind of protruding plugs, then you create these 2 buttons. So you're kind of working from the bottom up structured approach. And I would say, some people might disagree, I would say that creating this part with using a bottom up approach encapsulates design intent better than doing a subtractive approach. Because if you wanted to edit one of these, say you wanted to edit the height of like this button right here, then it would be a lot easier than if you had to edit an entire mold or an entire, cutting away feature. So that's just a short example. Hopefully that illustrated it. Next, we'll go into drawing interpretation. So throughout these 6 weeks, we'll be using drawings to basically model off our parts, model off our assemblies. So it is very important for you guys to learn how to look at drawings, how to interpret drawings, and how to figure out what features you need to apply in order to make the part.
Awesome. So, for drawings, the reason why we need to learn how to read engineering drawings, some examples we'll show on the next couple of slides, is it's basically the common language between everyone from how designing the part in order to actually creating in the end, so engineering and manufacturing. And it is universally applicable across all CAD softwares. And basically, if you take an engineering drawing from SolidWorks, you can design it in Fusion, CATIA, or AutoCAD, anything. And ideally, it will have a couple features on it that'll help you identify whether you actually created the part correctly. And in SWUG, the assignments will be given in drawing form because that is just the industry standard, basically. And here's the drawing. So there's a lot right here. And you will eventually learn how to read all of this. But essentially, we're going to break it down like section by section. So this on the top right is the overall view of the part you're trying to create. And my roommate is outside right now. But so this is an isometric view. And can anyone tell me what an isometric view is? I mean, it is up there, but like definition-wise? Someone? Yeah, it's essentially a combination between all 3 of these views right here. So from the front, the right, and the top, from like 45-degree angle. And so, essentially, you have like, take like a cube, for example. You have the front and the back, and the left and the right, and the top and the bottom, so 6 faces. And you can create views not only with isometric, but from all 6 of those faces. And so this is from the top, this is from the right, and the front. And then this title block down here is sort of like what gives you all the information about the block you're trying to create. So in this example, this is the power strip. It gives you the units, actually. So this is created in inches, pounds, and seconds. It's just a standard. There's a couple other ones. We'll go over those later. The material, and then the weight. So this will be the answer to all of the assignments you have, just to make sure that your part was created correctly. Oh, yeah. And it also has the scale, which isn't as necessary nowadays because we can just have the dimension, like as it's stated kind of up here. But the scale is down there as well. And if there are multiple sheets, pay attention to this because some of our assignments do have more than one sheet. But in this case, it's just sheet 1 of 1. And so the first couple of them that we're going to show have to do with curved dimensions and linear dimensions. And they're pretty self-explanatory. So linear dimensions, this is just a length dimension from the very top to the very bottom right here. This is 13.4. And then if you look down here, this will be inches because of the units that it's in. And this little circle right here means diameter, and the R means radius. And I'm going over these a little fast because all of this right here is all for your reference later. So when you get the slides, you can look and be like, okay, this is how it is on the drawing. But just so that we have enough time to cover all of the sketches that we're going to create today in class, we're just going to go through it a little quickly. But is this too fast for anyone? Like, is this a good speed? Cool. Awesome. And usually when you have like 8x right here or 2x, sometimes you have to type it manually, but sometimes you can just put it in. That means that the dimension can be applied to another location on that part that has the same feature. So for example, when this says 8 times radius of 0.25, that's because it's in these 4 corners, but also on the inside of this little little thing, if you can see. Because if you look on the isometric view, you'll see that there's a little edge right here that protrudes. And same thing with the diameter dimension. Both of these on and off buttons have the same size, and so it's just 2 times in order to prevent cluttering of the drawing. And even further, in order to see just dimensions that are inside a part, dashed lines will commonly indicate a hidden line. And then right here, there's a couple more. So they're right in the middle of here. It's kind of hard to see. But in the center of circles, there's this thing called a, is it the center line? The center mark. Yeah. I'm trying to, because there's a difference between, I guess, if there's a bore that you can see vertically versus a bore that you're looking straight into. And the center mark is just a cross, and it'll tell you, hey, this is a hole. And or a hole, or just the opposite of that, so just a long cylinder that goes up. And then a long to short indicates the center line. And that's essentially just like the middle right here. So if you can see, there's like a really long line right here, and then it cuts off, and then it goes short right here. But it's kind of, you just got to take a look at the drawing and figure it out. But you don't really need to pay very close attention to these. These are kind of just so you can get an intuition of how the part is laid out. And then here are some more views. So you have top, bottom, left, right, and then front and back. But you also have You also have detailed views. So right here, this circle that has an A on it will actually just expand basically to over here. And instead of a scale of 1 to 5, this is a scale of 2 to 5. And it will include a couple more dimensions so that you can dimension it. And there's a lot on this one. This is one of the more complicated parts that we've designed. But it just basically shows that here we're going to have a radius, we're going to have a diameter, and we're going to have a couple of linear dimensions over here. And then auxiliary views are essentially taken from a specific like cut on the object, and it's taken off of like another view. So this in of itself is like a top view or a side view of an object, and basically taking an auxiliary view of that takes a sort of slice off of that. And it's kind of like, it takes a little bit of intuition to figure out exactly what you want to use auxiliary views for. I typically don't use them, but I use detailed views a lot more often. You'll find a lot of these on our parts. And then for section views, it just cuts it in the middle. And these dashed lines, right, or this like scratched part, the scored area, means that this is actually part of the model that it cut through. And so then you can see exactly kind of the inner geometry of that. And then a crop view is essentially the same thing, except, or it's essentially the same thing as the detail view, except it's just, you take a different kind of section. Instead of like a circle, it'll be like a sketch. And then the last couple, bear with me, this is a break view. So if you have a really long part, you don't want it to clutter the entire drawing, because how are you supposed to see what these dimensions are if you need to include the entire thing on the drawing? So a break view will just be like, okay, listen, this will cut here and then resume over here, and then that way you can model these without cluttering the drawing. And then a broken out section view, the last one of these, it's essentially the same thing as a section view right here, except maybe there's some parts on this surface that you don't want to cut off. So you only have a little bit of it broken out into a section view. Any questions on all of that? It's a lot, but these slides are here for you guys to reference. And you don't need to worry about creating drawings or the names of the drawings quite yet. They will be on the CSWA, so the associate exam, but you can just take a look at these drawings, or just take a look at these slides when you're even taking the exam. So, because it's not super necessary. Did you?
Hello, hello. All right, we're gonna go into SolidWorks terminology. So these are gonna be all the file types. This is, well, and then file names and parts. So whenever you see a file or save it, you'll see the dot, whatever. And then these are some symbols and icons when you open up SolidWorks that tells you that's a part, an assembly, and a drawing. Cool. These you don't, STL is useful for 3D printing, so you export, you save like a part as an STL, and then you can bring it into a slicer, and a slicer basically tells, or the slicer basically reads the STL file and says, hey, I know how to make this into code for the printer to read, and then it spits out G code. So yeah. But mostly we'll be working with these three. This you don't need to worry about too much. This is just for templates if you want to make your own custom template or drawing template. That's how we have our own SolidWorks drawings with our little logo on the side. But yeah, these are the general type of common file types. All right. Okay, so this is going to be a lot, and there's a lot on the screen. So let's see. Number one is the menu bar. So on the top, oh, I don't have a, I have a pointer for a reason. All right. So on the top over here, this is a this is the menu bar. It just has a bunch of stuff. You know, save, like there's like drop downs and stuff. You can go and look into that when we get there. Number two, toolbars. So this is going to be like, so there's a bunch of buttons here, like the measure tool. This is the one I'm pointing to here. You'll use that a lot if you want to check your dimensions, evaluate. There's a bunch of other, this is a bunch of tools that you can just use on the top bar. There's three, the command manager. Okay, the command manager is really important. You're going to be using that a lot, especially when you're going from sketches to features to assemblies, and then there's also an evaluate tab. So you can, yeah. All right. And there's a configuration manager. You don't necessarily need to know that, but that's for if you want to make a configurable part. 5 is a property manager. It just has the properties of the material because you can choose properties. Yeah, okay. Feature breadcrumbs. I actually don't know the names of these, honestly. But these are really important. I just know that this is the sidebar, and that's important. But yeah, okay. So, okay, last few things. Is the design tree. The design tree is very important because that's where you're going to be actually modeling your part and having stuff in the assemblies. You're going to be, there's also a rollback bar which rolls it back up and down. So it can actually show you how you designed the actual part. But yeah, I think that's almost everything. 9. Oh, status bar. It's just there's a little thing on the bottom of SolidWorks. You can't see it, but it's just saying this is the version of SolidWorks, and you can change the IP, change the units also there. Okay. There's heads-up toolbar here, SolidWorks search, help menu, 4 task plane, 5 graphics area. Some of these I'm covering the names of. They're not really too important. You'll see how we will use them once we get into actual CADing. Okay. Oh, I guess we're going over to the design tree because I said it's really important, and we're going over it again. Okay. So this is the model name and the work-in model. There's the material here, and then there's a global reference geometry. So when you open a SolidWorks part, you will generally see all this except the features. The features you will add. That's the thing that makes the part. But yeah, this reference geometry is basically always exists. There's a front plane, top plane, right plane, because when you're in a 3D space, where do you begin? We're just gonna set, so this is like your reference point on where you start making your parts. Yeah. Yeah, and then you can also like rename your sketch if you want to and change some stuff if you right click. But we will get to that later. All right, so time to finally open SolidWorks. Woohoo!
And now, for the people who don't have SolidWorks currently open, just take a peek at your neighbor's computer, because this is just kind of the introduction to the SolidWorks UI and everything that we use it for.
You what? You just have on your, you just like in the Westwood email. There's a lot of Okay, so if you guys are on Windows, to open any regular Windows application, right, you just click the Windows key. SolidWorks. If you guys have a different version of SolidWorks, so in this case, this is Colin's computer. He's running 2022 to 23. You have 2024. You have 2022. It doesn't really matter. SolidWorks honestly doesn't change that much, but they still charge the same license fee renewal. 2023. I apologize. Okay, but can I just get like a hands raised of people who have it open, have SolidWorks open? Okay. How are you doing, Saudi? Okay, so I think at least one person per table has it, so that one person who has it probably will get very popular, but anyway. I'll just go ahead and get started for those who do have it open. So once you have this screen, you may or may not see this welcome screen in the middle that says Welcome SolidWorks. If you don't see it, that's fine. You can just go up to the top where it says SolidWorks here. Click on that little arrow to uncollapse the menu. Go to File, New. You can also say Control-N if you're into keyboard shortcuts. And then you click Part, and you click OK. Does anybody need me to run through that again? Okay. I'll just close this one. So up here on the top toolbar, File, New, Part, OK. Again, Control-N if you guys want to get to that faster. Does anybody need me to wait for a couple of seconds? Please raise your hand if you do. Okay. Yes. Oh. Okay, Colin wants me to announce that if you just requested your CSNet account, it will take a couple of days for them to activate it. So unfortunately, if that is your way of accessing SolidWorks, you won't be able to launch it in time for this workshop. But if you can't, just follow along, and hopefully you'll remember some things when you watch the recordings. Okay, I'm going to go ahead and start with the actual modeling process. If anyone does not want me to start yet and needs a couple more seconds, please raise your hand. Oh my. Okay. So first thing we'll do is we'll open up the drawing. So if you guys have the email, if you guys don't have it, that's fine. But we're just going to go ahead and go to this slide, which has the drawing. So could anyone tell me what is the name of this part? It's slightly obvious. Okay, I hear keychain. That is correct. It is the keychain. Could anyone tell me what the unit system is of this part? No. MMGS, that's correct. Yeah, MMGS stands for millimeter gram second, millimeter. The other one that he said was IPS, which stands for inch pound second. That's the American one. But this one in this case is MMGS. So you know from this that all length dimensions in this case on this drawing will be modeled in millimeters. Grams is the weight measurement, and second is, that's a universal time constant or unit. Next, the material is right underneath it. It says PVC rigid. So we'll apply this shortly when we get to SolidWorks. And this material is used to calculate all of your properties, like your weight, using the volume of the part. So just before we actually go back to SOLIDWORKS, could anyone tell me what an optimal modeling approach might be? Like, what would be the first thing that you create, followed by the second, followed by the third, looking at these views that are present on this drawing? Okay. Yeah. So for those who didn't hear, he said like the foundation, the rectangle part, which also kind of includes the hole right here. Then next would probably be this little bar, and next your name. And so the name is actually why there's no weight listed, because everyone has a different name, so the weight will differ. So yeah, operating off of that, we'll just go ahead and go back to SOLIDWORKS. So this is what your SOLIDWORKS should look like once you created a new part. As stated before in your feature manager design tree, you should have your material. It should say not specified. You haven't specified material. Then you should have your front plane, your top plane, your right plane, and your origin. Now, if these are not shown, meaning they're hidden like they are here, meaning you can't see anything, you can just click on one, hold Shift, click on right, and it selects everything. So this is just general Windows behavior. And then once you have those selected, just right-click, and then click that little, I guess, eye icon, Show. So again, that's select the front plane, Shift, hold, click right plane, right-click, and then now I just hit it again, but Show. Can everybody who has it in this state raise your hand? Okay, that's not the majority. Could everyone? Yeah. So yeah, if you guys need help, please raise your hand. I'm just going to linger here for maybe another 30 seconds for you guys to catch up. Okay, so it seems like most of you guys have it like this. So I'm just going to continue. Again, if you guys have questions, feel free to raise your hand. But the next thing what we're going to do is we're going to verify a unit system is correct. So in order to do that, we're going to go to the bottom right-hand corner. Bottom right-hand corner, right now it says custom. For you, it'll probably either say MMGS or IPS. Yeah, sorry. Yeah. So right now we're going to change it to MMGS. Again, because in the drawing it says MMGS, so we're going to change it to MMGS. Again, that's the bottom right-hand corner, very bottom right-hand corner. MMGS, right there. Okay, next we're going to define our material from the drawing. Referring back to the drawing, you can see it is PVC rigid. So in order to change the material, I'm going to go to where it says material not specified. Click on it using the left mouse button, then right-click, then click Edit Material. Again, that's left-click on Material Not Specified, right-click, Edit Material. Then once you have the screen open, in the search box, type in PVC Rigid. There should only be one result under the folder Plastics. Click it, click Apply, then click Close. Does anybody need me to run through that again? Okay. So click on the material. It should say material not specified, or I'll just remove it. So it says material not specified, left click, then right click, click Edit Material, click Search, click Enter in PVC Rigid, click on PVC Rigid, click Apply, click Close. Is everybody good, or need another run through? Okay. Okay, so once you have the material defined, then we're basically set up to begin our first sketch. Okay. So as stated before, our first sketch is going to be the foundation here. So the foundation in this case is going to be this not including the name, not including this bar. It's just going to be this very bottom feature. So if we go ahead and go back to SolidWorks, now we know, now actually we know that this is going to be on the top plane because we can see that this is the top view. So that means that the sketch will be created on the top plane. So if we go back to SolidWorks, we click on the top plane, then we right click, then we click on sketch. Again, right click on top plane and click sketch. You can also, alternatively, you can also go to the design tree on the left, and where it says top plane, you can also right click on that and click sketch. Both of them work. And in case your view does not look like this, where you are looking onto the top plane, you can go to the feature manager design tree, and where it says sketch, you right click on sketch and click normal to. Again, that's right click on sketch, then normal to. Okay, so once you have this, then we can start actually drawing our sketch. So can anyone tell me what the dominant feature is? Like what's like the first feature I should create, or like the first sketch feature I should create for that? Keychain hole. Okay, he says keychain hole. Does anybody else have a different response? Something else that we would create first? Okay, the rectangle. So of course there's no wrong answer. You can create either one first. I personally would create the rectangle because it is the bigger feature. So we're just going to go ahead with that. But sorry, the hole is also fine. So in order to do a rectangle, we can go up to here, click on the little drop down, and select corner rectangle. Again, that's up here in the top left, drop down corner rectangle. And then click on the origin. So the origin in SolidWorks will always be represented by this kind of red axis system. And so we will click the dot in the bottom of the axis system, and then we pull out until we see this rectangle moving along with our mouse cursor, and then we will click anywhere. Just make sure it kind of looks like a rectangle. It's okay if it doesn't look pretty, as long as it sort of looks like one. Does anybody need me to run through that again? No? Okay, so once you have the rectangle, you can go ahead and press escape to cancel. So as you can see, when I press escape, that means that there's no longer an icon below my mouse cursor with a rectangle. So again, this is the icon, this is my mouse with the icon of rectangle, meaning that I'm in the rectangle creation mode. Press escape, then I cancel out. So this is just regular selection mode. I can do, I can select stuff, manipulate stuff. So here SolidWorks it's a good time to introduce a SolidWorks concept called definition. So as you can see in the bottom right-hand corner, or maybe not so well see. Okay, no, you can't see it. It says underdefined, kind of right where my mouse is. Yours probably should also say underdefined there as well. And so what this means is that the sketch can be moved, or the sketch can be altered, meaning it's not fully defined by way of dimensions. So what this means practically is that if you take any one of these blue lines or blue points, say this one, and you click and you drag it, you can move it around. So that means it's not fully defined, right? You also take this line, you can move it around, take this line, move up and down, etc. So in order to fully define this, we need to apply dimensions. And where we find dimensions is in the drawing, right? So can anyone tell me what the dimensions I should put in for the rectangle? 30 by 120? Okay, does everybody agree with that? 30 by 120? Yeah? Okay, good. Yes, that's correct, 30 by 120. So we can see our vertical dimension is 30 by 120. So in order to apply that, we'll go up to Smart Dimension in the upper left-hand corner. Click Smart Dimension. And then we'll go ahead and click this line. So we click the line, and then we move it away from the line, and then we should see this dimension moving around. And if we click, then it places it. And then it pops up with this modify screen. And so we should enter in 30. And you don't need to enter in millimeters. SOLIDWORKS will automatically assume that's millimeters because the unit system is mmgs. And we press enter, and it applies it. So again, if you guys want me to run through that again, smart dimension, you click on this edge, and then you go out and you say 30 millimeters. The alternative way is to first select the top edge, then select the bottom edge, then go out to the side and say 30 millimeters. Both of them accomplish the same result. And then escape again to cancel everything and exit from whatever tool you have. So next, we're going to apply the 120 millimeter dimension. Again, smart dimension, upper left-hand corner. And this time, we're going to put it on the bottom. Oops, selected the wrong thing. Bottom, go down, 120. And now we have a slight problem. We cannot see all of our sketch. So SOLIDWORKS has a very handy tool that's called Fit All In. And in order to activate this tool, we can go up to the top toolbar here. And this very leftmost, it says, oh, sorry, it's called Zoom to Fit, sorry. Zoom to Fit, you click that, and then everything that is shown will automatically be moved into your visible area. So again, that's on the top in the HUD, they call it the HUD. And you click Zoom to Fit, and it'll fit everything in view. The faster way is to press F on your keyboard. You just press F on anything, on any view. If something is outside of your view, you just press F, and everything will automatically be centered. Is everyone following along? Does anybody need some extra time? No? Okay. So now actually our sketch in its current state is fully defined. As you can see on the bottom right-hand corner, it says fully defined. And if I try to drag any one of these points or any one of these edges, it won't budge, meaning it's fully defined. Now there's also another non-visual indicator. On the left in the Feature Manager design tree, if you remember before, it had a minus sign. So there's a parentheses, and it says minus sign, and then end close parentheses, and then the name of the sketch. In this case, it's now gone, meaning it's fully defined. But we're not done, right? We still need those two holes, or these two circles, that define the hole. So in order to do this, we'll create two circles. And the interesting thing now about these drawings is that you can often assume a lot of things. So in this case, we can assume that these holes are centered in relation in the vertical dimension, simply because there's nothing else that indicates that it's not centered in the vertical dimension. So if we go ahead and assume that, then we'll go back to SOLIDWORKS. We'll click on the circle tool, again in the upper left-hand corner. Click circle. If it's under something else, just click the drop down and then select circle instead of perimeter circle. So once you have the circle, then we want to go ahead and actually select the midpoint of this left edge. In order to do that, you hover over the edge while it's orange, and then there should be this little box that appears in the middle of it, and you can click on it, and it'll automatically put it in the middle of that edge. And then now you have the circle, and then we can just put it to a reasonable size, and then click again to place. Again, that's for the hovering. Then take the circle, hover over the edge, go to the center, click, and then click to place. So now that we have one circle, we'll just create another circle. So we'll go back up, repeat the same thing, circle, click the middle point, and then create the smaller circle inside of it. Does anybody need me to run through that again? We'll do that. We'll do that. Yeah, later. Yeah. That's fine. That's fine. Yeah. Yeah. So that's actually a good point. He was bringing up that he has a center rectangle on the origin. So that's the other type of rectangle. That's a center rectangle. In this case, you define the center first, and then you pull out, and you define the other edges. But either one is fine. So once we have this, then we can go ahead and define the diameters of our circles. So if we go back to our drawing, we can see that the outer circle has a diameter of 15. Again, this is a symbol for diameter. This kind of looks like a zero, like a big zero with like a slash through it. says this means a diameter of 15 millimeters. So we can go ahead and apply that. So smart dimension again, click the outermost circle, pull out, then enter in 15, press enter. And then we'll do that for the other circle, but in this case it has a diameter of 7 millimeters. So again, smart dimension. Oh, sorry, I haven't told you guys how to zoom. So to zoom, use scroll wheel. SOLIDWORKS by default has maybe an unnatural scrolling setting, where if you scroll down, really? Oh, yours is reverse? He has natural scrolling? Oh, okay. Well, if you guys want to switch the scrolling behavior, so if you scroll, if you want to have the opposite of what SOLIDWORKS is currently configured, you can go up to the search bar, search for options. And options should pop up. Press enter, and search options. Click mouse or enter in mouse, and then where it says reverse mouse wheel zoom direction, click that, and then check it. I'm going to check it even though this is Colin's computer, but since I'm used to it. And then you press OK. Does anyone need me to run through that again? Run through again. Okay, so on the search bar, go up to the top right, click search bar, and then just type in options. And it should be the first result, press enter. And then the search options box, type in mouse, and it should pop up with reverse mouse wheel zoom direction. And then you can check the box if you want to. Okay. So now that we know how to zoom in and out, we can just go ahead and zoom in. And we want to define the diameter dimension for the other one, the other circle. So this is 7, so we'll enter in 7, press enter. And now, once again, we have a fully defined sketch, as you can see in the bottom right-hand corner, or you can also see, again, in the feature manager. It's, once again, no parentheses and no minus sign. Is everybody good with this? Everybody's good? All right, thumbs up, I like it. Okay, so now we're actually done with this sketch, believe it or not. Took a lot of work, but we're done. And so now we can actually begin to create our first extrude feature. So to do this, go to the command manager at the top, click on the features tab. Again, that's command manager. Right now we're in the sketch tab, we want the features tab. Click features, click extruded boss base. Don't click the other ones, just click extruded boss base. Again, going back to the sketch, click features, extruded boss base. And these should be the default options. So where it says from, you have a couple of different options. We should leave it at sketch plane, but the other ones, just for educational purposes, is surface, face, plane, vertex, and offset. So if you wanted basically to define something else as a starting point, then the plane that you sketched it on, you can select these. We'll leave it at sketch plane for now. Then for direction 1, right now it's set to blind. Blind means that it just starts from the sketch plane and it goes normal to it in a certain direction that you define. And the length of that is defined by this D1 dimension. The other options are up to vertex. So if you had another vertex that was somewhere else in space, then you could select that vertex and it would extrude up to that point. Then surface, offset from surface up to body. And midplane is kind of interesting. This is if you want to preserve symmetry. So for example, I'm just going to do midplane and then, I don't know, just do like this. So as you can see, it extruded up and down by the same amount. But we'll just do blind for now. So leave it at blind. And if you don't like the direction that it's extruding in, you click this little reverse. So if you click it, it reverses it. But we'll just leave it going up. So going up is the correct. Next, we look and we try to find the thickness dimension that we want. So if you look back at the drawing, you can see that the thickness, actually, maybe this is a good question to ask you guys. What should the thickness be? 5? Okay, good. That's the correct answer, 5 millimeters. So instead of 10, we'll just go ahead and delete that and say 5. Press enter. And the preview updates. The yellow box is now showing 5 millimeters. As you can see, what I have selected right now is not correct, right? It doesn't look like the foundation of the keychain. So in order to remedy that, we'll go down to selected contours, click inside this box. If you don't have anything selected right now, it'll just appear like this, like an empty box. But select that box, and select the things that you want to extrude. So in this case, I want to extrude this, I want to extrude this, and I want to extrude this. So then it should look like this. And you want to verify that it looks like mine, just zoom in. And then it should look like this. The whole part at least should look like this. Does everybody have kind of something that looks like this? Who does not have something that looks like this? So if you have the error that says when you click on boss extrude that you need to first select a plane for which to extrude off of. So for example, that's something like this. If you have this error screen, don't panic, just click X, then click on this sketch, and then click extruded boss base, and then you'll pop out the window. So you just need to pre-select it. You either need to be inside the sketch, or you need to pre-select the sketch that you want to use. So I'll just pre-fill in 5 millimeters. And then right now we have the entire sketch selected. So if you want to clear anything, you just right-click on the box, clear selections, and then I'll reselect everything that I want to extrude. And then if we're all good at this point, please raise your hand now if you're not good. Okay, so if we're all good, then we can proceed to go ahead and click the check mark. And now if we zoom out, we can see that we have the entire solid foundation. So now, since we have a solid body, now is a good time to introduce how to rotate and how to move around your views in SOLIDWORKS. So the easiest way to introduce this is to press the space key, the space bar. Press the space bar, then it'll blow up and I'll have this huge box that appears. And then you can click any one of these boxes' faces to move to that corresponding view. So for example, if I wanted the top view, I can click the top of the box. Again, press space. If I wanted the front view, I can click the front. If I wanted the right view, I can click the right, and so on and so forth. And if I wanted the isometric view, I can go into this orientation box that pops up here, and then click on isometric in the upper right-hand corner. And this returns the view to like a more normal state. Does anybody need me to run through that again? Okay, so press the space bar, and if you want to view any face or any view, then you'll just go ahead and click on that corresponding face of the box. So for front, I would click this, press space again. If I want top, then I'll click that. If I want the right, then I'll click that. Is that good? Okay. Okay, and I'll just bring it back to isometric for now. It may prove a little tiring to keep pressing the spacebar and keep clicking, so the keyboard shortcut for isometric view is Control-7. So if you press Control-7, it actually combines isometric and fit all. So for example, if I was like really zoomed in, like I don't know where anything is, I press Control-7, it automatically brings it isometric and fits all. So now if we have everything in this state, we can go ahead and create our second feature, which is going to be this bar underneath our name. So to create this, we need to click on the top surface of the keychain, or what we have now of the keychain, right click and click sketch. So same process as with the plane, the top plane. This time you're just clicking on a surface. So the rules for SOLIDWORKS sketching is that you're allowed to create a sketch, a normal sketch, on any surface that is planar or flat. So you're not able to create it on surfaces that are curved or that have like a weird angle to them. For that, you can create a 3D sketch, but those are more complicated. We won't get into those. And you probably won't ever need to learn how to do those. So now, if we're in the sketching plane, then we'll go ahead and just create a simple box. In this case, for educational purposes, I'll just create it with the five. In this case, for educational purposes, I'll just create a center rectangle. So click center rectangle. Again, if you don't see this center rectangle symbol, just click the drop down and then select center rectangle. So I want to center rectangle. I'll put it in the approximate place where I want it or should be. So I'll first click the center, then drag out, and then, you know, that looks somewhat reasonable. Press escape to cancel. Anybody need me to run through that again? One person? Okay. So I'll just delete. So again, center rectangle. Click the center point, drag out until it looks reasonable, click to place, and then that's it. Sure. So if you don't have center rectangle, go to where the rectangles are, click on the drop down, click center rectangle, click the center point, drag out, place. So now we should have something that looks like this. And you may notice, again, I'm just going to keep hammering this point in, that this sketch is undefined, underdefined, because you can see in the feature manager there's a minus sign, and also below it says underdefined. So that means I can just literally drag around this rectangle wherever I please. I can change the height of it, etc. So now, once we have this rectangle in place, we can go ahead and first define its coincidence with the middle of this rectangle. Because again, if it looks like it's in the middle, it probably is in the middle. So this looks like it's in the middle of this rectangle, so it probably is. And in order to do that, we'll make use of the midpoint of an edge again. So in this case, we want the midpoint of this top edge. So in this case, actually, the plane is kind of interfering with my selection. So in this case, I'll just rotate it, and then I'll select the edge. It's still interfering, so in this case, I'll click on the plane, and then I'll click hide, and now I can select it. So again, if a plane is interfering, just go to the left, the feature manager design tree, click on the plane, and then click hide. And so now we can select the edge. So let's click on the edge to select it. We'll right click on the edge, and then we'll click select midpoint. And then you should only have one point selected at this point, which is the midpoint of this edge. Again, select the edge, right click, select midpoint. Which rectangle? The one that's blue right now? Oh, we haven't defined it yet. Yeah, no dimensions. Yeah, as of right now. Yeah. Again, okay. So again, select the top edge, right click, select midpoint. Top edge, right click, select midpoint. Okay, I think we should be mostly good to proceed. Again, if you guys have problems, please raise your hand. So the next thing that we'll do is we will define the dimensions of our rectangle. So if we go back to our drawing, we can see that the height of this rectangle is 5 millimeters and the width is 100 millimeters. So again, this is 100 because you can see the dimension edges are to the edges of this rectangle, and then same for the 5 millimeter one. So again, we go to Smart Dimension in the upper left-hand corner, click it, click on the left edge, and then we want this to be 5. Click the bottom, and we want this to be 100. Now again, this looks kind of weird because the sketch is kind of not top down. So again, we right click on the sketch and we click normal 2. Does everyone have these 2 dimensions? 2 dimensions, yeah. Do it again. Oh. Okay, so I saw quite a few people with this issue, that some of their relations were not being able to be applied because of a fixed relation. So basically, what happens what a fix is that if you click a point, for example, at the center rectangle point, and you accidentally click fix and add relations here, what this does, it basically fixes this point. So whatever you add to it, it won't be able to move it. So generally, we do not want fixed relations. So if you see that the error is happening, it's likely because you have a fixed relation. So click on the point again. Property should appear, and then in existing relations, click fixed, and click delete. So if you see a fixed relation, it's probably not supposed to be there. You should delete it. So again, click on the point, and then click, well, in this case, I don't have a fixed relation, but now I do. And for the fixed relation, right-click, delete. Okay, so we can go ahead and proceed. So now we have, of course, yeah. So if a fixed relation basically fixes whatever you apply the fixed relation to in space. So that means it cannot move in any way. So for example, if I was to apply it to the center point of this rectangle, by clicking on that point, then clicking on add relations, then click fix, then it appears, and then that means that everything automatically becomes fully defined because nothing can move. It just basically fixes that point in space. So generally, we do not want those. So if you see that, when you click your point, and it says like fix with a number after it, then you want to right-click it and click delete. And then at that point, like whatever you apply afterwards should be able to apply without issues. Okay, so now at this point, the only dimension we have left to apply is this dimension that says 3 millimeters. This is dimensioning the bottom edge of this kind of smaller rectangular prism to the bottom of this larger one. So we'll go ahead and apply that smart dimension, upper left-hand corner, select the bottom of that smaller rectangle, then click the bottom of the larger rectangle that I've already created. Place the dimension, enter 3, press enter. And now everything turns to black, and there's fully defined in the bottom right-hand corner, and the sketch says it's fully defined. Yeah, sure. So I'll just Control Z. Control Z is to undo in SolidWorks. So this is the point that we were at. We click Smart Dimension. We click this bottom edge, and we click the other bottom edge of the boss feature that I've already created, and we drag out to the side, place the dimension, enter 3, press enter. And at this point, everything is fully defined. Anybody need me to repeat that again? 3, sorry. So do it again, sure. So I'll Control Z, just remove everything. Smart Dimension, upper left-hand corner. Click this bottom edge. Click this bottom edge. Place. Enter 3, press enter. And it's fully defined. Do it again.
She wants you to do it again.
Do it again, okay.
Or I guess I can.
Okay. Okay, I'll just wait for like 10 seconds. Okay, so if we have this, then the very next thing to do is go up to Features in the upper left-hand corner again. Click Extruded Boss Base again. And this time we want a height of, again, 5 millimeters, as you can see in the drawing here. So we want to enter in 5. It is 5. And press OK to create the boss feature. Run through it again. Features. Extruded boss base. Verify that 5 is inputted. Click the check mark. And it's created. Middle mouse to rotate. Sorry, I didn't say that before. Anybody need me to do that again? Do it again. So at this point, fully defined sketch. Go up to Features, upper left-hand corner. Go to Extruded Boss Base. Verify that 5 millimeters is in the dimension box. Then press the check mark to indicate that you want to proceed. And then at this point, it's created. We all good? Or again? I'll be happy to do it again. Okay, so at this point, we only have one more feature left, and that is our name, which makes it uniquely ours, of course. So in order to create our name, we'll just go ahead and click on the same top surface of the keychain as before. Click on the sketch icon again. At this point, we're going to use a semi-advanced SOLIDWORKS sketch feature called Convert Entities. So in the upper command manager, you can see what says trim entities, and right next to it says convert entities. I want to click convert entities. It pops up with this window. The box should be pre-selected. If it's not, you need to select the box. Then we're going to select this top edge of the box that we just created. I'll run through that again. So click on the top face, then create sketch, then go to this top toolbar, then click convert entities. Pre-select the box, or select the box so it's blue, then click on this top edge. And then when we press the OK button, then it actually will generate in line. So what convert entities does is it creates geometry based on existing features. So for example, I could convert this top edge as well. So you can see that it just created it right here. And this is now part of our sketch. And the cool thing is that SOLIDWORKS will automatically regenerate and update these features when you update the feature that was created off of. So this is it's always linked together. And this is really useful if you're dealing with very complicated parts where there needs to be tight tolerances, if edges need to be related to one another, and so forth. So you'll probably be using this quite a lot. So for convert entities, click the edge, this edge, click the edge. So convert entities and then click the edge. So basically convert entities takes the projection of that feature and then pulls it to that sketch plane and then creates whatever geometry results from that. So for example, if I was to take this circle, click, and then convert entities, it creates a circle in the sketch plane. Does that make sense? Not really? Not really? Okay, so basically so the reason why we use convert entities is so that things are related to one another. So everything right here is fully defined because we use convert entities. If we didn't use convert entities and we just created a circle in the same position with a smart dimension, then when we update it, if we updated this circle in the original sketch, because remember we created that circle in the beginning sketch. If we updated it and then we saved it and we rebuild the model, if we just created it the normal way, then this circle would not update its value. It would not link. There's no link, right? Sure. Yeah. So convert entities is really powerful because of the linking properties. It has a link. It preserves that link. Okay. Yep. Yes, once you have the edge selected, yeah. Any other questions? Anyone want me to redo? Sorry, what? Just one edge. Sorry, yeah. Sorry, yeah. I'll just go ahead and delete this other edge. So just click and then delete. Press delete. The explanation about convert entities or the creation of this edge? Sorry, like the theory of convert entities or how to create the edge? How to create okay, so to create the edge, you go to convert entities on the top, then click this edge, then press the OK. Okay, so once we have this, I'll just go ahead and delete. If you didn't know already or you didn't figure it out, if you left click and hold, then it'll appear like this selection box, and anything that's captured within the selection box will be automatically selected. So this is really useful if you don't want to use control. You just left click, hold, and then if I drag it over everything, it automatically selects everything. And so in this case, I want to delete this because I don't need it, so I'll just select it using the box and press delete. So it's pretty useful if you're dealing with a lot of stuff that you accidentally created, you want to quickly delete. But anyway, so we have this edge created. And so what we want to do is convert this to what's called a construction element. So we want to click on the edge that was just created. We want to right click on it And then on this little thing that says construction geometry, it has this line that goes to a dashed line. You want to click that. And then once you click that, you can kind of see that the edge is no longer solid. It's kind of dashed, right? So again, click on the edge that was created using convert entities, right click, and then this, and then click on construction geometry. And then this, when you hover over it, you should see this dash pattern. And this construction geometry works with any sketch geometry that you create. So construction geometry is not extruded. It's not considered as extrudable features by SOLIDWORKS. So it's useful as construction geometry. If you don't want it to be extruded, but you want to relate it to something else, then you create construction geometry. The dash line, yes. So when you see a dash line here, that means that's construction geometry, and you create it by clicking the feature that you want to create construction, right click, and click here. And again, this construction geometry is not extrudable. Okay, yeah. So the question was, why do we use construction geometry? And the answer is because if you want to relate things to another thing but you don't want to extrude the original thing. So in this case, it's actually a good example because this edge has already been created. So we don't want to extrude it again, but we do want to relate stuff to this edge. So we create construction geometry that's related to the edge. Does that make sense? Okay. Any other questions? That was a good question. Okay, so once we have this construction geometry edge, then we can go ahead to the upper toolbar here, click text. Again, that's up here, this little A symbol. Click the A symbol. Okay, I'll do it one more time. So the A symbol, click the A symbol, and then where it says curves, if this box is not blue, just click it, and it become blue. That means that you've pre-selected the box for selection. Click, and then click that construction geometry that you've already created. And you click it, and so it should pop up with the name of your line. Should be a line with random numbers at the end. Anybody need me to repeat that? No? Okay, so then you enter in your name in text, or literally anything else. It doesn't have to be your name. I'm just going to put my name, so Abraham. And you may have this error, but it's not really an error. It's just, it's the wrong orientation. So you just mess with these options underneath here. So this just flips it to the other side. So I want it to be on this side, and then this just flips the orientation. And then I also want it to be on the other side, so I'll just mess with this justification as well. If you want it in the center, that's up to you. Just basically play around with these until you find something that looks okay. Yeah. Yeah. So if your text is upside down, once again, you just go to these little options underneath these little buttons, and you just you can flip it using these. You can change the right to left or left to right. Yeah. If you want to change the justification, you just go to these justification symbols. Any questions regarding that? Okay, so if you have it in this form, it is kind of small. So maybe we want to make it bigger. That's not required, but this looks better. We'll uncheck Use Document Font. So then the font button becomes ungrayed. Click Font. Then we can just change, the height. So maybe I'll just put it to 10 millimeters. Press Enter, and it becomes bigger. This is not required. Again, this is just purely cosmetic. So again, usually it's checked, Use Document Font, just uncheck it. Click Font. Where it says Units, just change it to something like 10. Depending on the length of your name, you might want to use a smaller or a larger number. But this looks reasonable. So at this point, it's just a simple extrude, and we're done. So we'll just go to Features. Oops, sorry, I need to press OK on Sketch Text. Go to features, extruded boss base. 5 millimeters again, according to the drawing, because everything is in line. There's no hidden lines. There's nothing, and the isometric view is also verified that everything is on the same plane, same height. So 5, verify that's 5, then click OK. And we're done. Yeah. Oh, yeah. So Sadi asked, how do we fully define the text? And the answer is, you can't. It's not entirely possible to define text because, it's just no, unfortunately not. Yeah, at least not that I'm aware of. But yeah. No, yeah. So at this point, we're done. Anyone who is not done, please raise your hand or is having trouble. Sorry, okay, so before you guys leave, just some wrap up to do. So we actually had 2 more parts scheduled to do, but it's fine. You guys had a lot of good questions, a lot of good progress. And so we can save these for homework if you guys want, or you guys can just attempt the homework. So homework will be emailed out after this workshop. If you have any questions at all, feel free to join the Discord server and then DM us. Yeah, okay.
Strongly encouraged.
Strongly encouraged. And challenge problems are optional but highly encouraged. And this recording will be posted to our YouTube channel, so subscribe. Again, it's on that card link. And these slides have actually already been emailed. Please fill out this feedback form for feedback on how we did this workshop. This is our first workshop in a series format. So hopefully we did well, but if we didn't, or if we did, either way, send us some feedback.
Wait, everybody needs to fill this out before
What? Sorry. I'll go over that. Yeah, I'll go over that in the next one. Yeah. Actually, I'll just say it now. So, in order to enter the raffle, fill in the sign-in form, and also, according to our publicity director, you also need to follow us on Instagram. I don't know how we're going to check, but
I will say it again. Okay. For the raffle, For the raffle, you also have to be following the Instagram. So we have a new Instagram. Everything's on the card over there, okay? So scan the card or go to our westwoodswug.card.co. All our links are on there, including the Discord, Meetup. If you're not in the Meetup, do that too, because that's how we get resources for you guys and how we're gonna do like raffles and stuff in the future. But the more people on the Meetup, the more resources we can get everybody, right? But join the Discord especially just for like updates in terms of like workshops and everything. But with the Instagram, we have a new Instagram and we're trying to like promote that more. So with the raffle itself, in order to win the raffle, we're gonna check how much. I will check if you are following the Instagram. So you guys should be all following the Instagram, okay? So follow it if you have not. There should be like 40 new follows today. But it's called Westwood SWUG. All of them, it's the same name. But yeah.
So the raffle will be held on week 6. And so for every sign-in that you do, and of course, Instagram follow, then that counts for 1 raffle ticket. Yeah. Okay, that's a good question. So the prizes are $125 gift card from the vendor of your choice, and also official SolidWorks branded merchandise that we receive directly from Dassault Systems. So there's 2 T-shirts, there's a water bottle, there's a keychain, there's a flashlight, pop socket, etc. So yeah, pretty good.
Who still needed help? Raise your hand.